You don't know what happened, Johan. Maybe due to our blessing with you here, you'll find that this one.
It's perfect. Yeah, that should be something. But I know already that the mass, because I just looked, of course,
Yeah, what's?
that the mass is way less than the other two.
Yeah, because it's shorter also.
No, even with taking into account.
Another hand.
Now, tell him. I'm not going to tell.
Yeah, so we took out the. We had two memory, and then there was a little bit with the third one, which is the one inside here. And it was connected up to the gas. Thursday.
Ah,
And we're doing it again. We're doing 2030. Make sure there's no more data, of course, before we can.
I have a question here.
yes.
That we are giving one bar in
Yeah.
yellow, and then the green line shows, system shows that it is going to be
Yeah,
one bar.
because this
But
is
how
our-
much volume is flowing? We cannot judge from here. How much volume of the gas?
What's the system volume?
Yes.
Or what your flow is in milliliters a minute? So what the system milliliters is?
That makes one bar pressure.
Yeah.
How much flow of gas is required to make one bar pressure here?
That's this one. That's milliliters a minute.
But this is that we want to equate the system, right?
Yes.
I mean, this green
But yeah,
volume
but
showing that.
what you need to feed is always also your leakage.
Okay.
You know what I mean?
I mean, this much volume is leaking from the.
Yeah, because it's
And
asking
system
for a
is-
certain pressure. What goes in is the amount that it's asking, what it's also losing on the back. But it want to have a certain standard value, so there has to be something added. So immediately the amount of feed is what he loses on the background, and in this case your membrane. Put this one a little bit faster up. I
Yes.
don't care.
But this one surely will not break.
Small
Because
one.
when you don't care.
No, I think there is more leakage. I guess. I hope, maybe. There can be already still some membrane. That's possible because there is a layer. You see a layer. But I see it already increasing a little bit slower with 50 milliliters a minute compared to what we had before. On the other hand, it's shorter, that's true, but 90 millimeters compared to 120 millimeters. That's a quarter less. So yeah.
Then why you suddenly open the low flow?
Now or just
No,
before?
when it going to be reached at 3.
Because with this one, it's so fast filling up that you have an overshoot in pressure,
Okay.
and the overshoot has to be decreased. But if the system is almost dense, it takes you so much time. That's why I don't want to have an overshoot or just a slight one, that you win time in the decreased part.
Looks like different layers got peeled off. So how is it going until now? We are doing the small one, that's one bar or what?
Three.
Wow, you're courageous. You really want to test the system, huh?
Yeah. Yeah.
You're at 10 bar now.
Three.
Oh, 3, okay. Yeah. But you have the impression that the alpha luminal layer is coming off, or it's palladium? Alpha is coming off.
Yeah, it started in the middle in a spot where you can see something. That was my doubt. But later on, you see on the rest of the layer that the alpha layer is peeling off
Yeah.
with it because of forces, etc. that exist. And then the question is there already just in that original part already something in the support,
That is-
or is it something external that
Yeah.
there was there what we couldn't see?
Yeah, so this is the inner pole support.
Yeah.
Okay, we've coated the alpha luminar layer.
Yeah.
What first thing to be checked in on this layer is the calcination temperature. The calcination temperature of the alpha luminar. Well, we don't.
Yeah, but maybe something in suspension or preparation.
Yeah, no, could also-
everything can
Could also be because let's say we.
pre-treatment.
Yeah, I know there can be all kinds of things in here, but that's at least something which probably relatively easy to check
Yeah.
the calcination temperature. If there's maybe set wrong setting or something that could be because in the end we need it. But for the intermediate phase, the calcination temperature has to be high enough to give, let's say, rigidity to the layer that we apply. And it could, for example, be that we set the oven to the right temperature, but still that there is something, a mismatch with the thermocouple or something, so that it doesn't reach
This
the temperature
one
that we would like.
was just, it was at 3 bars continuously, but exactly at 50 milliliters a minute. Exactly, that's the most strange value you can have, because that's the maximum of the flow controller. And then it can be the 50 milliliters, but it can also be more, that it's in a way not reacting properly. That's why I go down, because it's easier to...
So 171 is actually leaking from the.
yeah, from the system and the membrane. So we will check now again if it's tight enough.
1200, 1300 is still.
Because if we have 100 milliliter leakage through another part.
I think we should have, we have this 1300 that we see here, but I'm not sure, but that's one of the first things to check.
This one was closed, and this is good tightened, so
So it means that this is
170 milliliters or
From
something.
the
we will-
membrane.
Yeah, through the leaking through this layer.
our dense layer in the PD layer.
Yeah, but
So 171.
I don't think it's. We will take a look again. I don't think this is dense.
Dense.
Okay.
Oh, it's the
I
first
presume.
one. It was also not dense.
It was dense because it was building up pressure, and we reached, I think, 2.6 bar, and then suddenly it snaps. So it was dense.
So it was not because of the palladium layer. It was maybe because of the interlayer or our raw tube
There was an
quality.
influence, and if that support layer, or already at the surface, or somewhere else, that just like a post, and somewhere you have an influence that causes it, and then it wraps
So
up.
my tube was also dense, but the gamma aluminium was not good.